This video is something of a change of pace. It may look at first like it's unrelated to time value of money, but we will use it in later videos. We could also look at this as just a separate topic. We're looking at the relationship between nominal rates of return, the inflation rate, and the real rate. Now, the common way to look at this is to think that the real rate of return, which is of course the inflation-adjusted rate, that the real rate of return just equals the nominal rate minus the inflation rate. But it doesn't actually work like that. It's instead of being just a sort of add and subtract approach, it's actually a multiplication and divide type of approach. So here's what it looks like. If we are setting a rate from advance, from before the fact, and we think inflation is going to be a particular rate, and if we want to achieve a certain real rate, then we would set the nominal rate as follows. 1 plus the nominal rate would be 1 plus the real rate that we hope to achieve times 1 plus the inflation rate that we expect. And then to set that nominal rate, we could subtract 1 from both sides. And 1 plus the real rate times 1 plus the inflation rate minus 1 would be the nominal rate that we would set. Or we may look at this from after the fact to figure out what real rate of return we earned. In that case, the real rate of return is equal to 1 plus the nominal rate divided by 1 plus the inflation rate minus 1. So here's an example. You expect inflation to be 4% during the year. You want to earn an inflation-adjusted rate of 3%. What nominal rate will you have to earn during the year? Well, imagine that you invest $100 today, and at 4% inflation, you would have to have $104 at the end of 1 year just to stay even. If you want a 3% increase in your purchasing power, how much will you need at the end of the year? Well, you'll need 3% more than 104. That is $104 times 1.03, which is $107.12. That is, you'd have to earn $7.12 on a $100 investment, which means you would have to have a 7.12% rate of return. Now, let's look at it from after the fact. You invest in a CD that will pay, or we can even say pays, 6.5% interest. If the inflation rate is or was 3.5%, what would be your rate of return? Well, using the part of the equation, the second version of the equation here, real equals 1 plus nominal divided by 1 plus inflation minus 1, it looks like this, 1.065 divided by 1.035, so we've got our 6.5 and our 3.5, minus 1 equals 0.0290. Now that's rather easy to do on our BA2 Plus calculator. We can just turn on the calculator and clear whatever's in there. I've already set this to 4 decimal places, but you can follow this in order to get to your 4 decimal places or 2 decimal places. I'm going to just go ahead and do it real quickly. If I said second, format, 2, enter, and cleared everything, I'd be at 2 decimal places, but I want to be at 4 decimal places. So I'm going to say second format, that's the period key, second format, 4, enter, clear, and you see I have, it shows 4 because I pushed the 4 button, but if I hit the clear entry, I'm at 4 decimal places with no number showing. And now all I have to do is plug in the numbers just like this. 1.065 divided by, I'll try that again, 1.065 divided by 1.035 minus 1 times 100 equals 2.8986. That's our 2.90. Now you might wonder, why did I bother to multiply by 100? Well, the reason I might do that is because I might plan to use that 2.89 in a subsequent calculation, and the interest rate that I'd have to use would not be in decimal form, it would be in percentage form. That's why I might do that. Actually, this is becomes sort of second nature. It seems sort of convoluted when you first see it, but really, if you get used to it, 1.065 divided by 1.035 minus 1 times 100 equals, and that's how long it takes, and that's how long it'll take you when you get practice.